Here's problem 2618. Determine the energy stored in the 60 microfarad capacitor shown. We have a circuit which has 50 volts. We have a 25 microfarad capacitor up here, a 40 microfarad capacitor here, and a 60 microfarad capacitor here. Now, to find the energy, we want to either use 1/2 CV squared or 1/2 Q squared over C. In other words, if I can find either the voltage on that 60 microfarad capacitor or the charge on that 60 microfarad capacitor, I could use one of these two equations to calculate the energy stored. So that's my objective. To get there, I'm going to simplify the circuit first. So I'm going to add these two in parallel, and now my circuit looks like this. 50 volt battery, 25 microfarad capacitor here, and then when I add those two together, I'm going to get 100 microfarad capacitance for those two in parallel. Now I'm left with a series combination of a 25 with 100. My C series is equal to, since there's only two of them, will be product over the sum. So we'll have 25 times 100 over 25 plus 100. So that will be 2500 over 125, and so that will be 20 microfarads for that. Okay, so this whole circuit looks like this. A 50 volt battery with the equivalent capacitance of 20 microfarads. Nice to know. I've always wanted to know that. How is that going to help? Well, I can start to work my way back now to try to figure out either the voltage or the charge on that 60 microfarad capacitor. To begin with, I can calculate the charge on this equivalent overall capacitance. My charge is equal to the capacitance times the voltage, so that's going to be equal to, and this is my equivalent charge, that will be equal to 20 microfarads times 50 volts, or 1,000 microcoulombs. And that's what exists on this 20 microfarads. But that's also what will exist on the two capacitors in series, namely the 25 microfarads and the 100 microfarads, which form the series combination that form this equivalent capacitance. So in other words, the charge on the 100 microfarads is equal to 1,000 microcoulombs as well. Nice to know, because now I can use this idea to figure out the voltage on the 100 microfarads. Since Q is equal to CV in general, the voltage on the 100 microfarads is going to equal to its charge over its capacitance. And that will be equal to 1,000 microcoulombs over 100 microfarads. That will give me 10 volts. So there is 10 volts across this 100 microfarad capacitor. 10 volts. Well, that's between this point and this point in the circuit, which is the same 2 points as this in the original circuit. In other words, things in parallel have the same voltage, and they have the same voltage as their equivalent device, since they're connected between the same 2 points in the circuit, and that just represents a potential difference. So, with this in mind, the voltage on the 60 microfarad capacitor will be equal to the equivalent voltage on its equivalent capacitance, namely the 100 microfarads, and that will be equal to 10 volts. Now I know the voltage on the 60 microfarad capacitor, I can calculate its energy. The energy on the 60 microfarad capacitor is 1/2 C times the voltage squared. That will be 1/2 times 60 microfarads times 10 volts squared, and that will be, let's see, 100 times 30, or 3,000 microjoules. That is the energy stored in the 60 microfarad capacitor. I could write it as 3 millijoules. And that would be my answer. That's the energy stored in the 60 microfarad capacitor.